Hey guys, it's Miss Johnson and I'm here to bring you our last notes video for Unit 1. This is Unit 1 Note 6 on writing inequalities. Today our learning target is I can write and graph linear inequalities. Up at the top of your notes page, let's just review what these symbols are again. We've got 4 inequality symbols that we use mainly. This one, when the arrow is pointing to the left, is less than, meaning not as much as or fewer than. Arrow pointing to the right is greater than, which is more than. With a line underneath, now we start to include the value that it's at. So this one's less than or equal to, and the last one is greater than or equal to, meaning the values are bigger, but we also include the value that it's on. So let's just talk about how we would write some of these inequalities. Now we've got a bunch of different ways that we can write them. We've learned about standard form, slope-intercept form, and point-slope form, and we could be writing these in any one of those forms. So we'll just have to look at the information we get and go from there. In number 1, it says Hannah budgets $30 a month for lunch. On most days she brings her lunch. She can also buy lunch at the cafeteria or at a fast food restaurant. She spends an average of $3 for lunch in the cafeteria and an average of $6 for lunch at the restaurant. How many times a month can Hannah buy her lunch with the remaining budget? So what we need is something for X and something for Y. We have 2 unknowns here. One is going to be the number of times that she buys lunch at the cafeteria, so we'll call that X, and then Y is going to be the number of times that she buys lunch at the restaurant. Okay, so there's 2 unknowns going on here. Oh, that's our graph for later. So what we have to ask ourselves is what's happening to X and what's happening to Y. To X, buying lunch in the cafeteria, that is going to be $3. $3 cafeteria lunch. So we have 3 times every X. For Y, that's lunch in the restaurant, so plus 6 times every Y, and her total budget for the month is $30. So there's our equation that we can use to figure out where or how many times she can buy each type of lunch. Now, that equation is totally fine, but it's in standard form, so we can't necessarily graph it. So if we want to graph it, we need to solve for Y. So that's what I'm going to do next. So I subtract the 3x, and that gives me 6y is equal to negative 3x plus 30. And then divide by 6. And that gives me y is equal to negative 1/2, because 3 over 6 is 1/2, negative 1/2 x plus 5. So that's the equation that I'm going to graph. Here's my coordinate plane. Don't forget that you always need to label your coordinate plane. Let's get that out of the way for now. So my x-axis is the cafeteria lunches. And my y-axis is restaurant lunches. And then I'm going to graph it. My y-intercept is positive 5, so I go up to positive 5, and then my slope is negative 1/2, so that's down 1 and over 2. Down 1 and over 2, down 1 and over 2, and I'm going to go all the way down until I get to that x-axis. Okay, so this is what we're looking at. And actually, this should have been an inequality. I'm sorry, let me back up. This should actually be less than or equal to $30 because she can spend up to $30, but she can't go over. So these are all less than or equal to. And we divided by a positive number, so we didn't have to flip it. What that tells us is that where we need to shade. We need to shade underneath that solid line. So basically, any combination of lunches in that shaded region fits into her budget. Let's say she buys 2 cafeteria lunches and 2 restaurant lunches, she's within her budget. Let's say she buys 5 cafeteria lunches and 1 restaurant lunch, she's within her budget. She could buy 10 cafeteria lunches and no restaurant lunches, and she's within her budget because it's on that line and we're including those values. So any place in that shaded region is a solution to this question. Let's look at number 2. Rosa Padilla sells radio advertising in 30-second and 60-second interval time slots. During every hour, there are up to 15 minutes available for commercials. How many commercial slots can she sell for 1 hour of broadcasting? Let X be the number of 30-second commercials and Y be the number of 60-second commercials. Okay, so there's a couple things going on in this question. Well, one, they already gave you the X and the Y. So X is 30-second, Y is 60-second. That's good. The time that we want these to go up to is 15 minutes. Okay, so 15 minutes is a different time scale or a different time frame than the 60 seconds and 30 seconds. So what we need to do is we need to convert our seconds into minutes. So I'm going to say that a 30-second commercial is actually 1/2 of a minute, and a 60-second commercial, they already told you, is 1 minute, which we all know. So now let's talk about how we might write this out. So a 1/2 a minute for every 30-second commercial, plus 1 minute for every 60-second commercial. We have a total of 15 minutes, and we can go up to, but not over 15 minutes. So our inequality symbol is going to be less than or equal to. Okay, so now we need to graph it. So this is my equation that I wrote. Now I'm going to solve it for y. Remember that having a 1 in front of that y doesn't mean anything. We don't need to divide by 1 because it doesn't change our answer. So I'm going to subtract the 1/2 x. And that leaves me with y is less than or equal to negative 1/2 x plus 15. And again, I don't have anything to divide by, so I'm done here. My equation is ready to be graphed. So now let's label our axes. The x is 30-second commercials, and the y is 60-second commercials. Okay, so we can have 15 60-second commercials, meaning my y-intercept is up to 15, and no 30-second commercials. And then from there, we go down 1 and right 2 all the way down. Down 1, right 2, down 1, right 2, down 1, right 2. Now, you can do some math in your head and figure out that they're going to be able to have 30-second commercials, because for each 1/2 a minute, which means I'm all going to be all the way out here to wherever the 30 is going to be. That's where my line is going to eventually cross the x-axis. So for the 30-second commercials, I'm way off the coordinate plane, but that's okay. We'll just graph the piece that we can see. My line is solid because I'm including the values on that line, and the shading is below again, meaning any sort of range in that shaded region will work. There's a whole lot of options for the number of 30-second and 60-second commercials that we could have for that show. Shade all the way up to that line there. And again, this would continue out all the way down to the 30 if our coordinate plane extended that far. Okay, next question. It says, Lee Cooper writes and edits short articles for a local newspaper. It takes her about an hour to write an article and about a 1/2 an hour to edit an article. If Lee works up to 8 hours in a day, how many articles can she write and edit in one day? Okay, so again, we need two variables. We have the time for her to write and the time for her to edit. So writing and editing. I'm going to call X the writing and Y the editing. I should say the number of hours that she writes and the number of hours that she edits. So we have to consider what's happening to X and what's happening to Y. To X, it's about 1 hour. So we have 1 times every X. And for the editing, it's a 1/2 an hour. So that's plus 1/2 times every Y. Now she can only work up to 8 hours in a day. So that's going to have to be less than or equal to 8 hours. That's the equation that we need to write. Again, it's an equation in standard form, so in order to graph it, I want to move that x term over. I'm going to subtract x. Remember that the 1 in front doesn't have to be written. So I have 1/2 y is less than or equal to negative x plus 8. Now I need to do some multiplying. I have 1/2 times y. So to get rid of that 1/2, I'm going to multiply by 2 over 1, or in other words, just 2. Okay, and that goes to both parts on the right-hand side there. So that's going to cancel that. That leaves me with y, which is good. Then I'm going to be less than or equal to still because I multiplied by a positive. I don't need to flip my sign. I distribute this 2 over here. That's negative 2x plus 16. All right, so that is the equation that I'm going to use to graph. So let's label our axes. X is writing articles, and Y is editing articles. My y-intercept is up at positive 16, and then my slope is negative 2, so that means I come down 2 and go over 1, down 2 and over 1, down 2 and over 1, down 2 over 1, and again, it's nice to go all the way down to that x-axis just so that you can see where that x-intercept is going to be. This is less than or equal to, so it's a solid line and shading underneath. All right. Let's flip over to the back and talk about the next 3 questions. So Coach Washington wants to take her softball team out for pizza and pop. Each large pizza costs $12 and each pitcher of pop costs $3. She doesn't want to spend more than 60 bucks. Write an inequality that represents the situation and graph the solution set. All right, so we have pizza and we have pop. I'm going to say X is the number of pizzas and Y is the number of pitchers of pop. So then what's happening to each variable? For pizza, it's $12 times every X. For pop, it's $3 times every Y. Total, 60 bucks. She doesn't want to spend over that, so it's got to be less than or equal to. That's the inequality that we're writing. It's again in standard form. You'll see that standard form happens a lot when we're writing out these situations. But now I need to put it in slope-intercept form so that I can put it on my graph. So I'm going to subtract the 12x. I have 3y is less than or equal to. These cannot go together. I haven't said that yet today, so make sure that you remember that these cannot go together. This is a constant that has an x term. They are not like terms. So negative 12x plus 60 and divide by the 3. I'm dividing by a positive, so my sign stays the same. Negative 12 divided by 3 is negative 4x. 60 divided by 3 is 20. All right, so that's the line that I'm going to graph. My y-intercept is up here at positive 20. My slope is negative 4. So negative 4 is going to come down to about 16, which is right about there, and then over to the 1. Pay attention to the way your axes are labeled. Look at this first line is actually only a half. The next line is the 1. Okay, and by the way, they already labeled the axes for us, so that's nice, that's helpful. So then if I go down 4 more from 16, that goes down to 12, which is going to be about right there, and then over to 2, and then go down 4 more, which is to 8, and go over 2. 4 more would be to 4, just below that 5 there, go over to 2 more to the 4, and then all the way down to 0 and go over to the 5. So there's my line, my boundary line, and then I want to shade underneath it. All right. So let's take a look at number 5. It says at Six Flags in Chicago, there is a flat admission fee of $25. For every special attraction X that you want to go on, it costs $5. Let Y represent the total cost of your trip to Six Flags. Write and graph an equation to represent the situation. Notice, by the way, that it says write and graph an equation. That means that we're not going to have any shading in this question because we're not talking about an inequality, we're just talking about an equation. So let's talk about our variables. X was the special attractions and Y is the total cost. So this equation is going to look a little bit different because we're going to have the total cost equaling whatever we're spending. Okay, so it's no longer going to be a standard form equation. We're actually now going to get a slope-intercept form equation. So what we're spending is $5 for every special attraction. That's 5 times X, plus the flat admission fee when you walk in the door of 25 bucks. Okay, that's what our equation looks like. So this is a slope-intercept form equation rather than a standard form equation because there's only one thing that's changing with each price. Okay, so the number of special attractions is what's going to change your price. This is a flat admission rate. Okay, so I don't need to worry about that having a variable. All right, so now let's graph it. One, we need to label our x's. So this is special attraction. And this is total cost. Also notice that these aren't labeled as far as the numbers go. So when we talk about labeling the values of the axis, for special attractions, I'm just going to count by ones. 1, 2, 3, 4, 5, 6, and so on. And you probably wouldn't have to, this graph is really small, so it might be hard to write there. You wouldn't necessarily need to write each one. Once I get to 6, I could write 7, 8, 9, 10, and then 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that's still enough to tell you what we're counting by, even if we don't write every single value on the line. But now let's talk about the y-axis. So the y-axis, I'm starting with a flat rate of 25 bucks and I'm increasing from there. So I'm not necessarily going to want to count by ones because I'm going to start all the way up at the top and run out of room really fast. So I'm going to count by fives. So I'm going to say that that's 5, 10, 15, 20, 25, 30, 35, 40, and so on. 50, 60, 65, 70, 75, 80, 85, 90, 95, 100. So again, I'm counting by fives, even though I'm not labeling every single one. I'm just labeling where I feel like I have room. So 115, 120. All right, so now let's graph it from there. My y-intercept is 25, so right away I'm starting up here. And then I go up 5 and over 1 for each attraction. So up 5 would go to the 30 and over to the 1. Up 5 over 1, up 5 over 1, up 5 over 1. And this is just an equation, not an inequality, so I don't need to worry about what kind of line or where I'm shading because it's just an equation. All right. Last one. It says the National Honor Society is doing a fundraising dance at Farmington High School. It costs 125 bucks for the DJ. Admission is $6. Write and graph an inequality to represent the total money Y that the National Honor Society could raise. Remember that you need to pay back the $125 for the DJ. Okay. So let's think about what we know. We know that the total money is going to be Y. We know that we need an X variable, but it's dependent on how many people go to the dance. So I'm going to say that X is the number of people who attend, and Y is the total cost. Okay, so what's happening to Y? Y is going to equal the $6 for every, because we're talking about the money that they make. How much could they raise? So they're raising $6 for every person that walks in the door. Yay, every person that walks in the door gives them $6. But don't forget that they have to pay back the DJ 125 bucks. So from that $6 times every person, I need to subtract 125 because I'm going to take $125 and hand it over to the DJ, which means I don't have it anymore. So really we have a negative y-intercept here. Okay, a negative y-intercept. So let's label our axes. X is going to be the number of people, and Y is going to be the cost, or not cost, I should say the total money raised. I didn't mean to put cost over here. I should have put total money raised. That's really what I wanted. And then I need to talk about what I'm going to count by. So I'm down 125. Now I realize that the coordinate plane um, on your page is only in this first quadrant up here. So if you want, you can just draw yourself a new x-axis kind of up a little bit. So I'm going to go down 125. Let's say I count by tens. So negative 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 20, 25. Woo! I'm way down here. 10, 20, 30, 40, we'll call that negative 50. Negative 60, 70, 80, 90, negative 100. If I go up, that's 10, 20, 30, 40, positive 50, 60, 70, 80, 90, 100. Okay, now the number of people, let's say maybe I count by, I don't know, fives, because we're hoping a lot of people attend the dance. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60 would be out here. So this is 35, 40, 45, 50. We'll do that. 5, 10. Okay. So now when I type all of this into my calculator, I know that my y-intercept, I already put it on there, is at negative 125. Holy buckets. So let's talk about how many people we need just to break even, just to get up to that x-axis. So if I have, let's say 20 people attend the dance, 20 times 6 is 120 bucks. I'm close. I'm at -5. So when 20 people attend the dance, I've raised $120, which means I'm at -5, which is right about there. So I'm getting close to positive. Let's say 30 people attend the dance. 30 times 6 is 180 minus the 125 we hand the DJ is 55. So if 30 people attend the dance, National Honor Society has made 55 bucks. Okay, let's say 50 people attend the dance. What's 50 times 6? 50 times 6 is 300 bucks. Subtract the 125, and I have $175. By the way, I'm doing a lot of this work on my calculator, which is what you can't see right now. That's where it's valuable for you to have your calculator out with you. So if 50 people attend the dance, then I'm up at 175 bucks, which is going to be like way off my graph up here. All right, so my line goes all the way up. Sorry, that's not an awesome straight line. Okay, kind of a funky graph to graph, and we could have changed what we counted by to make it look a little bit better, but that's what we did, so there it is. All right, so that's the end of our last video for Unit 1. Thanks for listening, and don't forget to check your notes sheets off with Miss Johnson, and I will see you all later.